Light, shadow and reflection. Learning objectives. Light and sources of light. Speed of light. Luminous and non-luminous bodies. Transparent, translucent and opaque bodies. How does light travel? Pinhole camera. Rays and beams. Shadow. Reflection. Activity 12.1. Prepare a list of sources of light, which you observe in your daily life. Light and sources of light. Imagine that we are in a completely dark room. We find it difficult to see and detect any of the objects present in the room. When we switch on a bulb, we can see everything in the room. Everything becomes visible. We can therefore say that light is a type of energy that helps to produce the sensation of sight in our eyes. We are able to see the objects around us due to presence of light. This light may be natural or man-made. You can see objects during daytime due to the light received from the sun. Thus, sun is the main source of light. The night sky is full of bright shining celestial bodies on a clear dust-free night. These celestial bodies are also capable of producing their own light. Humans can produce light by invented devices like the tube light, electric bulb, lantern, kerosene stove, candle etc. These are man-made sources of light which help us to see objects during dark in the absence of sunlight. Sun, stars, jugnu, bulb, candle. Some insects like jugnu and fish also emit light in darkness. Speed of light. Light travels very fast indeed, faster than any other object we know of. In early times, it was difficult to measure the speed of light. But now, it is possible to measure the speed of light not only in atmosphere but also in other media like water, glass etc. The speed of light in air is nearly 3 lakh kilometers per second, 3 lakh kilometers per second. It would take light only about 1/8 of a second to go from one end of the earth to a diametrically opposite point. Luminous and non-luminous bodies. The natural and man-made bodies that give out light are called luminous bodies. They include stars, including the sun, candles, oil lamps etc. All these sources shed hot light. But the bodies that shine with the light of other luminous objects and have no light of their own are called non-luminous bodies. Most objects in the world are non-luminous. Tables, chairs, tree, books, pens, pencils are all non-luminous bodies. Candle, oil lamp, stars, table, chair, tree. Transparent, translucent and opaque bodies. The windows of your house have panes of plain glass. You can look through these panes because light can pass through glass. Thus, the objects or materials through which light can pass are called transparent objects. Materials such as glass, water and air are examples of transparent object. If you look through a butter paper, you will not be able to see through it clearly because butter paper allows only some light to pass through it. Such objects are known as translucent objects. Materials such as oily/butter paper, tissue paper, ground smoked glass, muddy water, which transmit a small part of the light rays and are called translucent. Light passing into a glass through a torch or lens. Light passing into butter paper through torch. Now, take a thermocol sheet or a wooden sheet. Can you see through it? No, not at all. Because thermocol or wooden board do not allow light to pass through them at all. Such materials are called opaque materials. Wooden block, book, brick, wall are examples of some opaque objects. Light passing into a book through a torch. How does light travel? Light travels through its rays that travel in a straight line. Let us find it. 1. Look at the candle through a small pipe. You will find bulb rays entering straight into the pipe and reaching your eye. Now bend the pipe gently and try to look at the candle. You will not be able to see the candle. 2. Close the doors and windows of your room and let light enter inside through a small slit. You will see that a path of light comes inside through the slit. It will be quite straight. You can perform the following experiment to prove it in a laboratory. Seeing through a straight pipe. Seeing through a bent pipe. Sunlight coming out through hole into closed door. Activity 12.2. Take 3 equal-sized rectangular cardboard or thermocol pieces and keep them on the top of one another. Take a long pointed stick to make a hole, simultaneously, through all the 3 pieces. Put the pieces vertically on suitable stands and adjust their positions so that the holes on the pieces are all along the same straight line. An activity to show that light travels in a straight line. Take a lit candle and place it such that its filament is just before the hole of the cardboard at one end. Look toward the holes from the other end. You will be able to see the flame of the candle. What happens when we disturb any one of the pieces even slightly? Look at the flame of the candle. Can you see the flame of the candle? No, we cannot see the lit candle flame from the other side. This shows that light travels in a straight line. This property of light is called rectilinear propagation of light. Rectilinear propagation of light, thus, means that light travels along straight lines. Pinhole camera. The pinhole camera is a simple device of the property of rectilinear propagation of light. It can form images of bright objects on a screen. You can also make such a camera of your own. Take a cubicle box and paint its roof and the inside walls black. Cut off one of its sides and cover this open side of the box with tracing paper. This paper will act as the screen. Make a small pinhole near the center of the side of the box that lies opposite to the screen of butter paper or tracing paper. The pinhole camera is now ready for use. To use this camera, put it on a suitable stand with pinhole facing the object to be photographed. Place a flower in front of the pinhole and then look at the screen. You will see an inverted smaller image of the flower on the screen. As seen in the diagram, this image is formed because light travels in a straight line. Pinhole camera. Rays and beams. A very narrow path of light that can be represented by a straight line with an arrowhead at one end is called a ray of light. A broader path of light consisting of several rays traveling parallel to one another form a beam of light. The rays from any source of light, called a point source, go out in various directions. When these rays starting from a point source, then the collection of such rays is called a divergent beam of light. A light beam can also be convergent, when all rays come together and eventually meet at a point. Parallel beam of light. Divergent beam of light. Convergent beam of light. Shadow. As you know that opaque objects do not allow light to pass through them. Since light travels in a straight line, opaque object can make a dark region on a screen kept behind them. Thus, dark patch formed behind an opaque object when it is placed in the path of light is called shadow. Shadow of human beings. Activity 12.3. Let us take a torch and a flower pot and go into a dark room. Place the flower pot on the table and throw torch light on the flower pot. The flower pot, being an opaque object, will cut off some of the light of the torch and there would be a dark region on the wall. This is the shadow of the flower pot. The shadow of flower pot formed by the light of a torch. The size of a shadow depends on the comparative sizes of the object and position of the source of light. Let us see various possibilities using a wide source of light. Shadow formed by a pointed source of light. Consider an opaque object like a rubber ball coming in the path of the light emitted from a very tiny point source. If a screen is put beyond the ball, you will see a sharp dark shadow on the screen. The rays which start from the point M along MP and MQ fall on the screen at X and Y, respectively. The region between ball and screen does not receive any rays of light because the ball will stop all rays. The portion between X and Y will therefore be dark. As we move the screen farther away, the shadow grows in size. Shadow formed by a pointed source of light. Shadow formed by an extended source of light. Most of the light sources we use have a finite size or are extended sources of light. Consider the first case where the obstacle is bigger in size than source of light itself. The shadow formation in such a situation has two parts. Here we will find that the shadow on the screen is a kind of two-fold shadow. There is a complete dark region between X and Y on the screen which we call as the umbra. Another region outside the umbra that is partially dark is called the penumbra. Shadow formed by an extended source of light. Reflection. Reflection can be compared to the action of a ball rebounding from the ground. A ball thrown at right angles to the ground or a wall bounces back in the same line. The word reflect means to throw back or bounce back. Thus, when the light falls on a surface, and it is sent back or reflected, it is called reflection of light. Let us perform an activity. Activity 12.4. Let the light from a torch fall on the wall in a dark room. You will see a circular patch of light on the wall. Now let someone hold a mirror in hand at one corner of the room. Stand at another corner with a torch in your hand. Now direct the beam of the torch light onto the mirror. What do you see? You will see a patch of light appearing on the other side. Now, adjust the position of the plane mirror. The direction of the patch of light is immediately changed. Here is an activity that shows that the plane mirror is reflecting the light and light is traveling along straight lines. Regular and diffused reflection. You have noticed above that if a shining metal surface or a plane mirror is used to reflect light, we get blinding effect in your eyes. This is because when the rays of light fall on a smooth flat surface, they bounce back making a similar pattern. It is called a regular reflection of light. But when the rays of light fall on a rough uneven surface, the reflection of light from such surfaces take place in an irregular diffused manner. There is no glare in any particular direction. Most of them cannot be seen bouncing back. Such a reflection is called an irregular reflection or diffused reflection. Keywords. Luminous object, the objects which emit their own light. Non-luminous object, the objects which do not emit their own light. Transparent object, the objects which allow light to pass through them. Translucent object, the objects which allow light to pass only partially through them. Opaque object, a substance which does allow light to pass through it. Umbra, the dark inner region of a shadow. Penumbra, a region of partial darkness. Shadow, an area where light is blocked. Rectilinear propagation of light. The property due to which light travels in straight lines. Point source of light, a source of light of the size of pinhead. Summary. Light is a form of energy. An object which has its own light is called a source of light. There are two sources of light, natural and artificial. Objects that have their own light are called luminous objects. Objects that have their own light are called luminous objects. Light travels in a straight line. Transparent, translucent and opaque objects are classified on the basis of passing of the light rays through them. The region of the space where the light from the source does not reach, and hence is the darkest, is called umbra. The region where the light does not reach from all parts of the source is called penumbra. Shadow is a dark patch formed behind an opaque object placed in the path of light. Pinhole camera is based on the principle that light travels in straight lines. When light rays fall on the smooth surfaces, they get reflected in a similar manner.